Okay, time to start. Good morning. So yeah, this is our first time doing a morning class. After this, you could tell me if you like the class. I mean, as in like a morning class, prefer the morning over the evening, or if you want to switch back to the evening. Right? Integrations. That's what we're doing. We finish. Well, we have one more thing, one more rule to go through for indefinite integration. Good morning. We have one more rule to go through for indefinite integration, and then that's it for this part, right? And I plan to finish definite integration today as well, and the application of indefinite integration. So that's the plan for today, right? So our last class was all the way on Tuesday. So that was a while back. And this is what we did. We defined what integration is, and we said that it's the opposite of differentiation. And we learned the rule, we learned the symbol. We know that there are two types of integration, definite, indefinite integration and definite integration. This is what we were doing last time with the plus c, and that c is called the arbitrary constant. We did that already. Um, Indefinite integration, we said we must put the plus c for indefinite integration. C is the arbitrary constant. And this is the rule for indefinite integration. We did all this. We learned this rule. When you have sums and differences, you're required to integrate sums and differences. You're still applying the rule, this rule here. You're still applying this rule here. What you have to do is integrate each term. And then we practice that. This was the second rule. I showed you how it is possible to expand when we have like the value of the power is really low. So for example, if I wanted to find the integral of 2x minus 3 all squared, it's easy for me to expand those brackets like we did here. We expanded the brackets. Hold on, wait. No question. What was that one? Right. Sorry. We did this together. And when we did this one, we expanded the bracket. Why? Because we needed it into a form. We needed to put it into a form where we can integrate, right? And we said that form is ax to the power of n. Hence, we expanded this. But I told you there's also this rule. So instead of expanding the bracket, you can apply this rule, right? When you see an expression in this form, so ax plus b to some power, you can apply this rule. Like I said, for this one, 2x minus 3 all squared, you could have expanded the bracket. But this rule really comes in handy when you have like really high powers. 2x minus 1 to the power 7, 4 minus 3t to the power 5, this to the power 4. You're not going to sit down there and, multiply this by itself. Hold on, I have people joining. You're not going to sit down in the exam and multiply this by itself 7 times or multiply this by itself 5 times. That's just wasting time, right? And then you're more prone to errors. So that's where that rule comes in handy. We also learned about integration of trig. When you see it's in this form, sine ax plus b with respect to x, so dx. Good morning. This is the rule. It's minus 1 on a cos of ax plus b plus c. You remember the plus c? Why? Because this is indefinite integration. And today, we'll learn the difference between indefinite and definite integration. This is the rule for cosine. The cosine of ax plus b dx is 1 on a sine ax plus b plus c. Notice that the angle stays the same, right? We did that example. We did all these. This is the rule we're at now, right? So, fourth rule of indefinite integration. You'll notice that when we start definite integration, you see some of these rules, like this one, this one, and this one. So all of them apply to indefinite integration as well, right? You see what I'm talking about when we actually do that. So the fourth rule, what does the fourth rule say? Well, the integral of a f of x dx is the same as saying a, so whatever this value of a is, multiplied by the integral of f of x. So say they wanted you to integrate this expression, 3x to the power of 7. Yes, I can just apply the rule that I know. So don't be like me, right? This is plus c because we're doing indefinite integration. Remember that plus c. Do not be like me, put your plus c. Okay, so you could apply the rule of integration, of definite integration, the one that says the integral of ax to some power, to the power of n, dx. So this dx represents with respect to x. And to do this, we know the rule, right? Ax n plus 1, and then this whole thing divided by n plus 1. And of course, because we're doing indefinite integration, you plus c. So you could have applied that rule here. And what would you get? If I followed this rule right here, it's on the right-hand side. It says ax to the power of n plus 1. So this will be 3x, n plus 1, n refers to my power, right? So n plus 1 is 7 plus 1. Then I'm dividing by this new power as well. So I'm dividing by 7 plus 1. And of course, you plus c. Plus c. And you will still get 3x, well, 3x to the power of 8 on 8 plus c. Or you can rewrite it like this, right? 3/8 x to the power of 8. These two things, they're the same thing. So you could have applied the basic rule of integration. Hold on. People join in, right? Okay, hold on. People join in. Right. So you could have applied the basic rule of indefinite integration. Yeah, the basic rule, right? Do all of this. But this rule, you'll see it comes in handy for different when we're required to integrate different expressions, right? So in this case, if they asked me to integrate 3x to the power of 7, I could have used this, or I could apply this rule. The rule says the integral of a f of x dx is the same as saying a, so whatever this value of a is, multiplied by the integral of f of x with respect to x, right? So if I have the integral, I'm required to find the integral of 3x to the power of 7. I can take out the 3 and deal with this. So what I'm doing, I'm finding the integral of x to the power of 7 with respect to x. I'm ignoring the 3 for now. I'm just trying to find what's the integral of this. When you apply the rule, you get x to the power of 8 divided by 8. But then, remember it's 3, right? So it's 3 multiplied by this integral, and you get your answer. Remember to put plus c. Do you understand that? Yes? No?
Yes, miss, I follow.
Okay. So
Yes,
we're gonna
miss.
right? So, okay, yeah, sorry about that. So this is what we're doing. We're applying the rule that we saw just now. So this is the rule we're applying here, right? That's what we're practicing. Let's start with this one. Number 3. So according to my rule just now, this right here is the same as saying 2 multiply by whatever the integral is of sine 3x with respect to x. So this is where it comes in handy, right? We know a rule to integrate trig functions. So to integrate sine, right? If we're given sine, the rule is the integral of sine ax plus b with respect to x, so dx, is going to give me minus 1 on a cos, same angle, so I put back ax plus b, and of course a plus b. So now this right here, the integral of sine 3x with respect to x, I can now apply this rule because I know how to integrate this. I know a rule that will help me to integrate this. So that's where this fourth rule here comes in handy. Because if you look at this, right, and they ask you to find the integral of 2 sine 3x dx, you don't really know any rule that will help you integrate that. Why? This doesn't have any number in front of it. So this really isn't in a form that you know how to integrate, if you get what I'm saying. And that's why the fourth rule that I just showed you comes in handy. Because if I have the integral of 2 sine 3x dx, that's the same as saying 2 multiplied by the integral of sine 3x dx. I know how to integrate this. I know this rule. And therefore, I can now say this is 2 multiplied by, so according to my rule, it's minus 1 on a. A in this case is 3. Remember, a is the coefficient of x, right? What do I mean by coefficient of x? The number that comes right before the x. So in this case, it's 3. So that's minus a third. And according to my rule, it's cos the angle stays the same. So this is ax plus b. This remains ax plus b. If this is 3x, this would remain 3x plus c. But of course, now you have to multiply 2 by this to get, we need a different color, minus 2 on 3 cos of 3x. And because this is indefinite integration, put your plus. That is your answer. Everybody good with that?
Yes, miss.
Yes, miss.
The rules can be used together. What do you mean by that? Josh? What do you mean by if the rules can be used together?
Miss, I mean like in an equation you can use like two rules within the same problem, if that makes sense. You know what I'm saying?
Oh yeah. That's why I said integration, differentiation, it's all about the rule. Once you know the rule, you can do anything. So yeah. Can I clear this now?
Gracias, yes, miss. Miss, I'm finished now.
Okay, anybody writing this?
No, miss, I already have it.
Okay, clearing it now. So can you try this for me? Remember, all you're doing is following the rule. So I see your sum here, right? So an addition sign. That indicates to me that the rule I'm using, well, one of them would be, hold on, let me go back. This one. If I find sum, if I have sums of differences to integrate, all that means is I'm integrating each term. So because I saw that addition sign there, I know I'm going to apply this rule. Then you also saw the trig function. So you know you're going to apply this rule. But again, look at this. You have a number in front of your trig function. which implies to me that this rule would also apply. So yeah, you have to pick up on these things, right? It's all about using the rule. So yeah, let me know when you finish. So like I keep saying, integration, differentiation, it's all about using the rules, right? Once you know the rules, you're good to go. So I'm looking at this. They want me to integrate 3 cos x plus 2 sin x with respect to x. Well, the first thing you should pick up on is this addition sign here. This implies sum, right? Addition applies sum. We know a rule that we can use when we have sums and differences. What that rule basically states is that if I have sums and differences, so if I see an addition sign or subtraction sign, all I have to do is integrate each two. In this case, 3 cos x, that's my first term, 2 sin x is my second term. So according to that rule, when I have sums and differences, all I'm doing is integrating each two. So what does that mean for me? If I want to find the integral of 3 cos x plus 2 sin x, then it's the same as finding the integral of 3 cos x plus the integral dx. Put this in bracket. It's the same. So this is the same as this plus the integral of 2 sin x with respect to x. The next thing you should pick up on is that I have trig functions here. The fact that they want me to integrate, yeah, that's correct. Good job, Kitania. So the fact that they want me to integrate a trig function means that I have to apply that rule. There's a problem though. I have these numbers in front of my trig function. But that's okay, because I also know a rule on how to deal with these numbers in front of them. According to my rule, the integral of 3 cos x with respect to x is the same as saying 3 multiplied by the integral of cos x dx. Same thing here. I can take the 2 out, and this is multiplied by the integral of sin x dx. Now I have it in a form that I can work with. All you do is apply the rules. Like I said, the rules are very important for integration and differentiation. I know a rule on how to integrate cos x. If I follow that rule, I'm going to get 3 multiplied by the integral of cos x. It's 1 on a, right? In this case, a is 1. So that's saying 1 on 1, 1 on a. In this case, a is 1. So that's the same as saying 1 on 1 sine. And remember, the angle stays the same. X plus, doing the same thing here. That's the same as saying 2 multiplied by the integral of sine x. According to my rule, it's minus 1 on a. So minus 1, and a in this case, which is the coefficient of x, is 1 cos x. I simplify this. 1 on 1 is 1. So that's the same as saying 3 by sine x. Minus 1 on 1 is minus 2. Minus 2 multiplied by positive 2 is going to give me minus 2, and then cos x. But remember, you must put the plus c, because this is indefinite integration. Everybody good with that?
Yes, miss.
Yes, miss.
Can I clear it now?
Yes, miss. I learned this this week.
Okay, so do you understand it?
Yes, miss. I understand it.
Okay, cool. Wait, now let's try.
Yes, miss. I learned it at school this week. Miss, I'm using another device. Yes, miss, I got it as well.
Good job. So
You just change the cost on the sign. It's pretty easy.
wait, repeat.
No, just change the sign. Just change the cost to sign on on a sign to cost. It's pretty easy.
No, not necessarily. I mean, in this case, cos is going to sign, yeah, but sign has to go to minus cos.
Minus cost. Yeah.
So I see a difference here. I apply that first rule. So what does that first rule tell me? If I see a difference, all I'm doing is integrating each term. So in this case, my two terms, 3 cos theta and 5 sine theta. So I find the integral of 3 cos theta. Well, in this case, it will be x will be with respect to theta. And then minus the integral of 5 sine theta with respect to theta. There's a problem because I have numbers in front of the trig function. So what I do, I take them out. So I end up with this minus 5, the integral of sine theta with respect to theta. And now I can integrate. So this is the same as 3, the integral of cos theta. This would be sine theta. So the rule is from cos to sine is minus 1. I mean minus 1 now. It's 1 on a sine of whatever, right? In this case, a is 1. So it's 1 on 1, which is 1, right? So I can just leave it as sine theta minus 5. Oh my, wrong type of bracket. The integral of sine theta is going to give me minus cos theta. Don't forget the plus c. I simplify this even more to get 3 sine theta. Minus and a minus is going to give me a plus 5 cos theta plus c. This is my answer. Everybody good with that, right?
Yes, miss.
Yes, miss.
I'm going to end the meeting and rejoin.